Right, we are here at the Engineering Design Show 2025 in Coventry. And on our podcast stand right now, I have Rob Ronan from Retronix. So, Rob, for our audience that is unfamiliar with the Retronix brand, can you just give me a summary of what you guys do?
Okay, well, we do, I guess our bread and butter really is alloy conversion. So we're working with the military and aerospace industries, mainly taking the lead-free parts and then turning them back into leaded parts for those guys. But probably we do component testing as well, but our biggest growing market is component reclaim at the moment.
Right.
So can be anything from somebody sending us, they've made a mistake. They're sending us 10, 15 PCBs right up to tens of thousands coming in on pallets, literally.
Wow.
So they identify the costly parts on the PCBs that they're struggling to find, obsolescence or long lead times, and then we can reclaim them and then run them back through inspection, test, repackage, re-reel, and then ship them back out to them.
Right, wow, okay. We'll come on to that in a moment. We'll go into much more detail about that. There's a lot more I want to learn about that. But just in general, you're here at the show today. What are you hoping to sort of achieve from your day at the exhibition?
It's just to catch up, really. I've got a lot of current customers and current suppliers that we work with here. So it was more from that side of thing of having a catch up with those guys really today.
Yeah.
So I've been walking around to see some of the names on the wall there behind you. So, they've got ART, Rochester, Force, ABB, people like that. So we've just been catching up with those guys.
Yeah, brilliant. So networking.
Yes.
Yeah, for you. Now, on component reclamation, I'd like to know a lot more about this because in my mind, a manufacturer, they design a product, they make a product, they sell a product, it gets used, and then it probably ends up in landfill.
Exactly.
That's what we thought about. At what point do you guys get involved in reclamation? And talk me through the technicalities of that.
Yeah, I mean, I guess one of the driving forces for reclaiming is component shortages, and obviously obsolescence as well. So you've got CEMs or you've got OEMs that are, their purchasing departments are pulling their hair out, searching for a part. And chances are in stores somewhere, they've got a test bone pile or they've got a previous revision of that PCB that's got that part on, or those parts on. So a lot of the times it's cases like that where PCBs come to us, the customer will tell us this part, that part, that part, that part, and then we'll remove them, either scrap the board at the end, return the board to the customer, and then run the parts through tests, re-life them by retinning or reballing, and then package them how they want them and send them back so they get to reuse their parts. It's a lot safer than going out into the grey market. They brought those parts in the first place. They've got the full provenance of that part. It's a lot safer than, dip your toes into the grey market to try and source a part.
That's fascinating because that's the bit I didn't understand. So it's actually the customers has got stock of some boards.
Yeah.
From
could be an old revision,
prototyping, customer return, or what
PCB failure,
PCB failure, whatever it is. That's the bit I didn't understand. So it actually the board in terms of traceability is staying within that customer's lease effectively. And you're going in and you're taking those boards that would kind of gather in dust almost, disassembling them. Repurposing those chips that they want, let's say retinning, retesting, that sort of thing, and then they can go back into their manufacturing process.
Yes.
Okay.
Yeah,
I get that.
Yeah, so it's I mean, we're not reclaiming parts to then sell them into the open market.
Right.
The parts that we reclaim go back to the customer who sent the PCBs to us.
Yeah.
As I say that, they've got full traceability of that part because they bought it in the first place.
Yeah. So really thinking about it, it's incumbent on manufacturers, if they get to a point where they suddenly end up with a pallet of boards for whatever reason, like say a revision or a customer there's overordered or whatever it is. It's incumbent on them to think about the future and hold on to those boards rather than scrapping them.
Yes.
Yeah. And so they can then come into your workflow at a later date if necessary.
Exactly. I mean, it's also one of the added benefits of it is it's keeping some of this high value silicon out of the hands of counterfeiters.
Yeah.
Because if this stuff ends up in landfill, there's still a percentage of that finds its way back into the supply chain as counterfeited parts.
Sure.
So, if we're removing the high value parts off of it, that PCB is not quite as appealing to the counterfeiters then.
Give me a clue as to the nature and the type of the components you're reclaiming. I guess there must come a point in the kind of cost scenario where it's not viable.
Yeah.
So give me a clue as to the range of component types that you would recover.
It does tend to be the higher value silicon, but it's also, it could be anything right down to, tantalum cap.
Oh, really?
If there's a 52-week lead time on that path, and the customer needs to build within the next 6 weeks, and they can't source them anywhere else, then that suddenly becomes a valuable part.
So the value in the component depends upon
the needs.
Nature of the needs.
Yeah.
It's either obsolescence or unavailability.
Exactly. Yeah. I mean, during the last component crisis, shortages was when we really saw a huge spike in that sort of thing.
Wow. Talk me through, you mentioned sort of aerospace defense, that sort of thing. Talk me through the breadth of the markets that you work with.
It can be any one, really. I mean, it's from standard manufacturing companies through to military aerospace. At the moment, we're seeing a big upturn in like storage. So the long-term storage PCBs.
Okay.
Because they need to, they come out in the racks, and there could be maybe 20 of these PCBs in these racks. And at a certain time, they need to replace them because they go out of date so quickly.
Yeah.
But there's still parts on this revision that they're going to put on that new revision.
Okay.
And, in some cases, they might have only been in service for a year.
Wow.
Sat in a fairly inert atmosphere. We're not talking about helicopters or, aeroplane nasty positions to be in.
Yeah.
They sat in a fairly inert atmosphere. So why not reuse those parts?
Right. Yeah.
Yeah. So data storage is probably at the moment one of the biggest areas for the reclaim side of things.
It's interesting. Yeah, there's the whole AI industry unfolds and data center capacity increases.
Yes.
There's rate of change. It increases.
Everything's changing so quickly.
Yeah, so those board revisions could be happening quite frequently in that arena.
Yeah.
Interesting. In terms of just looking kind of at the UK at the moment, in terms of projecting forward over the next 24 months, there's a lot happening in the world. There are tariffs, there are price increases on certain semiconductor technologies. There's AI messing up the capacity. There's new technologies emerging, etc. Where do you see, just in general, UK manufacturing heading over the next couple of years?
I mean, like I say, a lot of our business is made up with military and aerospace, which it's always fairly steady. See, unfortunately, at the moment, that's kind of peaking, but I think AI is going to be a big factor. And we're currently talking to a customer who received a sample today on a very, very, very large AI chip template. I mean, it's into the 19,000 plus spheres on it that they need us to place onto this.
Sorry, so that again.
19,000.
19,000.
Yes.
Okay.
So we're involved. We're in a lucky position in that we deal with an awful lot of sectors in the industry, whether it's the component suppliers right through to the OEMs, but also the design guys as well. So when the designs are made, they want prototypes run, and especially if it's something that needs reballing, needs sewing balls put on them.
Because I'm thinking that in my mind, I was thinking, standard package, standard tooling, everything's fine. And then someone comes along with that.
Yes.
you're into a whole
Yes.
tooling bespoke projects.
Yeah. It's gonna push us, I'd say. But I mean, we've got a sample in now, so we'll start working on that sample, working with the customer, and we'll find a solution for them. That's what we did.
I'm just thinking of how you reflow a 19,000
Well,
volt.
we've got the laser pre-ball,
Right.
so we use a laser. So it's a non-reflow process.
Okay.
So the board sits at an ambient temperature, and the spheres drop down. The laser fires, reflows them, drops onto the pad, and then reforms.
So yes, limiting heat damage or dissipation.
Yeah, I mean, there's literally sat at ambient while that's happening.
Right.
And so, which is, again, one of the reasons we can reclaim parts, because we're not putting sensitive BGAs through, the reflow to put it on the PCB, the reflow to take it off the PCB, and then a reflow to refill it. We can skip that one.
Right. Yeah. So again, in terms of reliability, durability, and that sort of thing, critical
Yes.
to that process, keeping heat out of that process.
Yeah, very much so.
Cool. Well, I think we're coming to the conclusion of our interview. How do people get in touch with you if they've got boards?
Through the website, we've got for retronix.com, there's a quote requests line on there. I mean, they can make contact with me via LinkedIn as well. Yeah.
Have you got boots on the ground? Can you go on site to customers?
Yes.
You've got engineers that can.
Yeah, I mean, I'm based down south in Hampshire. The company's up in Glasgow, so I cover Scottish borders to Cornwall, basically.
And now I'm going to finish with two more unusual questions, a little bit more light-hearted. Who would be your biggest engineering hero of all time?
It's probably one of the guys I used to actually work with, to be honest.
Okay.
At a CEM company that I used to work for, he would just always seem to have the answer for absolutely everything. And it's I was quite young and impressionable at the time, and it changed the way that I approach things, and take it stage by stage to try and find the answer. Yeah. It's not always clear straight away.
Right. So yes. So for young engineers, I had a similar experience myself when I went into the engineering industry, finding a mentor.
A good mentor. Yeah.
Yes.
Key.
Who can point you in the right direction. Problem solving, which is a difficult process.
Exactly. Sometimes it's just watching how they take steps through that process.
Yes. In engineering, very easy to get caught in a loop
Yes.
of problem solving, looking for perfection when maybe you need to move on. Yeah, interesting. And my final question, of all the innovations in the world, which is the one you wish you had invented?
That'll be quite obvious here. I'm probably saying the mobile phone.
Mobile phone? Yeah.
Yeah. And you think about the impact that's had on everybody's lives.
Yeah.
And it spans the age range. It's not something that's just appealing to a certain range, right down from 10-year-olds up to 100-year-olds.
It's an interesting, because obviously I'm old enough to remember a world before mobile phones. Yeah. And I remember at the time, from a sustainability perspective, obviously mobile phones often get a kind of black mark against them. But in my mind, I don't need a separate camera. I don't need a voice recorder. I don't need a television set. I don't need a map. I don't need a computer. I don't need a GPS.
Yeah.
When you think about the amount of hardware that is not ending up in landfill because it's integrated, I see your point of view.
Yeah.
So, yes, tick.
Yeah.
Mobile comms.
Yes. 100%.
Excellent. Well, we've reached the end of our interview, Rob. Thank you very much for your time.
No
very enlightening questions, and very interesting to get to understand that circular loop.
Yeah.
Within the confines of customer age.
Circular economy is, I
get that now. Yeah, brilliant. Thank you very much.
No problem. Thank you.
Cool.
Cheers.